Okay, we're going to continue our conversation or lesson on the quadratic function. As we've said several times by now, quadratic function is anything with an x to the second power in it. And it can be written in the form of ax squared plus bx plus c. We expect a quadratic equation to come out with two solutions in most cases because it is a second degree. We also know that the graph of a quadratic function is going to be in the form of what we call a parabola. And of course a parabola looks something like this. And I'm not an artist, I probably haven't drawn that properly. Let's see if I can get it a little bit better than that. Something, making a horseshoe shape. And again, I haven't drawn it perfectly, but it's going to be something in that U shape. Every parabola has a few parts that we can identify that help us to sketch the graph. Graphing these can be quite complicated. However, today we're going to look at just a few properties of the parabola that we can gather from the equation or the function that make just making a rough sketch of it a pretty simple process. The first thing we're going to do whenever we get a quadratic function that we want to graph is we're going to identify A, B, and C. That's the coefficient of our quadratic, our linear, and our constant terms. If we can start off by identifying those, we can quickly gather some information that's going to help us identify, first off, the direction of opening, whether it's going to go up or down. Some of them go upwards, facing that way, and others go downwards, where they might be turned the opposite direction. The key here is to remember that A stands for attitude, and of course A being the coefficient of the quadratic term, it tells us the direction of the opening. If A is positive, or our attitude is positive, we're going to be in a smiley face. We'll be smiling, and our parabola, or our smiley face shape, will be pointing upward. If we have a negative attitude, or our A is negative, it's going to be frowning, which will be going downward. Just one little way you can help remember. Basically, positive points up and negative points down. That's pretty simple as well. Just a little clever play on it there. If your attitude is positive, you're smiling, your parabola is going up. If your attitude is negative, you're frowning and it's going down. So identifying A real quickly tells us the direction of the opening of the parabola. Very important information. Gives us a good feeling for what we can expect in the problem. Some things will come into play later on when we talk about maximum and minimum values as well there. The next thing we can find is the vertex. And in finding the vertex, what we're talking about is this point here, right at the center of the parabola, either at the very bottom, in the case of a parabola going upward, or at the very top, in the case of a parabola going downward. That point is the center point. In other words, everything is symmetric around that point, and knowing it can really help us out a lot if we're trying to graph the parabola out. Well, we can use A, B, and C to help us identify the vertex, B and A in particular, by first off realizing that at the vertex that the value of x is equal to negative b over 2a. And knowing that, of course, our parabola has a vertex with the coordinates x and y, and we can easily find that x by using this little formula. Now, once we get x, we can plug x into the equation, or into the function, to find y. And that helps us out a lot in locating our coordinates for the vertex, which would be in the form of x, y. So real quickly, we can identify the b value take the opposite of it and divide that by 2 times whatever the A value is, and that gives us our X coordinate. That's our X coordinate for the vertex, and we take it and plug that in to the whole function and find your Y coordinate. We'll do an example of this in just a moment, and I'll show you. It's actually a fairly simple process that is quite useful. Also, we can identify something called the y-intercept. We talked about the y-intercept before when we discussed graphing linear equations. You may remember it's the point at which the graph crosses the y-axis. And in this particular sketch I've got right here, that would be the y-intercept. Okay, so knowing that point is very useful for us because the parabola is symmetric. So if we know a point over here, we also know a point on this side somewhere, and that would help us find that. So finding the y-intercept is very simple actually if we know the equation of the function, and the y-intercept is always equal to the value c. C is equal to the y-intercept. Excuse me. Very important information. So real quickly, just by locating A, B, and C in the function, we can quickly identify the direction of opening, the vertex, and the y-intercept of that parabola. And that really can give us a lot of information that we need as we try and just make a rough sketch of the parabola. Now, as I said before, there are ways that you can get a little bit more specific, but for right now, this information is really all we're going to be concerned with because it helps us out enough to get a rough idea of what the parabola looks like. So let's look at an example here. We're going to graph the function of f of x equals x squared minus 4x plus 6. First off, we're going to stop and identify what A, B, and C are. Well, looking real quickly, we can tell that A, the coefficient of that is 1. B, our linear coefficient, would be -4. And C, the constant term, is 6. We're going to use this information to find all of this other stuff about the parabola that we need to know. First off, we'll go with our direction. Again, we'll look at A for attitude. In this case, A was +1, so we know that A is positive, so that means that our direction is going upward. Okay, it's going to do one of these deals right here. So that's important information to know to start off with. We know what to expect as we start to graph this thing out. Now, the next thing we're going to find is our vertex, and the vertex is quickly located again by saying the x-coordinate of that vertex is going to be equal to -b over 2a. Well, in this case, b is -4, so that is going to give us -4 divided by 2 times a, which is 2 times 1. Now, real quickly, -4 is 4, and 2 times 1 is 2, so we can say that in our vertex, x is equal to 4 over 2, which simplifies to be 2. That's important information. Now, to locate the actual vertex, we need the x-coordinate and the y-coordinate. Right now, we just have the x-coordinate, so we're going to take our x-coordinate of 2, plug it in to the function, and find the value of it. And that would tell us what our y is. So we're going to find the function of 2. So the function of 2 would be equal to 2 squared minus 4 times 2 plus 6. And again, I'm just taking this function right up here and plugging 2 in for all the x's. So the function of 2 is going to be equal to 2 squared, which is 4, -4 times 2, which would be -8, and then plus 6. So Real quickly, 4 minus 8 is negative 4 plus 6. That comes out to be 2 as well. So our y coordinate is 2, our x coordinate is 2, and our vertex, real quickly, is 2, 2. And I'm running out of space here, so I'm just going to kind of scribble it in here in this open area. 2, 2 is our vertex. So that tells us a lot. We know our vertex is at 2, 2. We know this thing is going upward from that point. And we also can locate our y-intercept real quickly by finding c. c is 6 in this case, so that means that our y-intercept is 6. So we have an upward opening, we have a vertex of 2, 2, and we have a y-intercept of 6. Now let's go see if we can use that information real quickly to graph this equation or this function. First off, we'll plot our vertex, which is at 2, 2. That's over 2 and up 2. That would be right there. And we know it's going upward, and we know we have a y-intercept of 6. That means that our parabola is going to cross the y-axis at the point 6. Well, again, we've talked briefly about this in the past. Our parabola has an imaginary line passing through that vertex we call the axis of symmetry, meaning that everything on one side of that axis is the same reflected on the other side. So if we know that this point here is at 6 on the y-axis, we know that there's going to be another point over here at that same level. I guess I should do that in green. At that same point on the other side. And it's just a reflection along that axis on the other side. So that gives us 2 points that we can go through from our vertex, and we're just going to kind of give a rough sketch of the parabola from there, knowing the general shape of parabolas and knowing what it's supposed to do. That's what our parabola should roughly look like. Again, there's other ways to find more specific values along that graph, but it gives us a very good feeling for exactly what that parabola is going to look like. And that's how we would graph it. Okay, let's look at another example. Our next example is graphing the function y equals negative 3x plus 12x minus 7. We'll go through this one a little quicker. A, as we see this, is negative 3. B is 12. And C is negative 7. Very important that you get your signs correct. We're going to use this information real quickly to find our direction. Since A, in this case, is negative 3, we have a negative A. So that means that our parabola is going to go downward. Okay, so this one's going to look a little different than our last one that was pointing upward. Real quickly, our vertex we can find by using x is equal to negative b over 2a. In this case, b is 12, so that would be negative 12 over 2 times a, which is negative 3. So we clean that up a little bit. That's negative 12 over negative 6. And negative 12 divided by negative 6 is going to tell us that x is equal to 2 again. That's coincidental that it came out to be the same thing, but we got a value of x is equal to 2. So now we're going to plug that in to our equation for x, and we'll find out what y is equal to. Y is equal to negative 3 times 2 squared plus 12 times 2 minus 7. So we plug that 2 in for the x, and we get this. 2 squared is 4. Negative 3 times 4 is negative 12. 12 times 2 is 24. And minus 7. So we have negative 12 plus 24 minus 7. And real quickly, you could probably figure that out. That's going to be equal to, that tells us y is equal to 5. So the coordinates of our vertex, real quickly, are 2, 5. That's our vertex. Very important information. We can actually go ahead and plot that if we wanted to. 2, 5 would be located, let's see, right here. And we know that the parabola is going to go downward from there. Our y-intercept comes out to be -7. So we know we're crossing the y-axis at -7. Well, that's all the way down here. And again, we can kind of imagine our axis of symmetry. It's a pretty lengthy one. I'm going to have to make it lengthy so we can see. Our axis of symmetry comes way down here. I haven't drawn it perfectly straight, but you get the point. We can come over here and get a good feel, and I'm having a little trouble seeing it on the projector here, but I believe it would be right about there on the other side. And that gives us the points that we need to sketch our parabola. Let's see if I can do this. And again, this is a rough sketch, but it's based on the facts that we're finding from A, B, and C. And we're using that information to find these parts. So this parabola looks quite a bit different than the last parabola that we did, but you can see it's very similar. Let's look at one more. I'm going to give you a little bit of time to try here. You can pause it here for a moment and try. First off, let's identify our direction, and we'll find our vertex and the y-intercept. Real quickly before we get started, I'll say A is 1/2, which might be a little interesting for some of you that don't like fractions. B is 4, and C is 5. All right, take that information real quickly and see if you can find the direction, the vertex, and the y-intercept. All right, now that you've done that, let's just real quickly go through. A was positive 1/2, so we know this direction is going upward since A is positive. So we have this. Our vertex we'll real quickly find with good old x equals -b over 2a, so that would be -4 over 2 times 1/2. Well, 2 times 1/2 is pretty simple. 2 times 1/2 comes out to be 1, so that's -4 over 1, which tells us x is equal to -4. So real quickly, we're going to plug -4 in, and we take that, so we have the f of -4 is going to be equal to 1/2 times -4, squared, plus 4 times -4 plus 5. And -4 squared is 16, so that's 1/2 times 16 plus 4 times -4, which would be -16. I'll just go ahead and put that as -16, and plus 5. 1/2 of 16 is 8. 8 minus 16 would be -8 plus 5. Gives us a y value of -3. So real quickly, our vertex is -4, -3. And we can plot that. -4, -3 would be right about here. And our y-intercept is 5, which we get from C, right there. And we would plot that real quickly. So we know, based on our symmetry, that we have a point over here as well on the opposite side of the axis of symmetry. And that gives us all that we need to graph our parabola. And let's see if I can sketch it real quickly. And again, I didn't do that perfectly, but again, it's just a rough sketch based on what we know, and it gives us a good idea of what the exact image of that parabola would be. Okay, thanks for listening, and hopefully you got a little bit of this. If you didn't, please feel free to ask some questions, and good luck.